So when this footprint is not enough, it's not sufficient enough, we proceed with the next type of fundament, which are line fundaments. We can make one fundament which connects several verticals. It's more rigid, it's heavier. For the fundament, it's important to be as heavy as possible. And when this is also not enough, we'll have a base slab, which is under the whole building, on one big slab of concrete under the whole building. And this is the most recently and most widely used type of base of the building, because it's most predictable. You can predict how the concrete can how the concrete will maybe move or crack, and how the soil will move under the building if that can this will occur. So from the statical point of view, or from the calculation point of view, we have a base point which can or cannot rotate. Actually, for the fundament, it's important to know what the type is, and does the column can rotate in the base point or not. Most of the columns did not rotate in the base point. They are rigidly connected to the ground. So, for example, when you want to move the building, the base stays where it is. The first floor, or the floors above the fundament, moves laterally, but the base doesn't move because there is no way to go. There is soil all around, so you cannot shift the ground. There is not such a big force that can move that amount of weight of the soil and the base. If there is such force, it will rip the ground. So yeah, we no longer talk about building, we talk about particles. So yeah, that's
geological
your field. So yeah, we will assume that the base will stay where it is.
Before the bomb.
Yeah, it doesn't matter what the forces and how they will apply on the construction. The base will stay where it is. Of course, now we are talking about most of the things we will talk about deflections in the structure, not structural properties like stiffness and so on, because we're about demolition and destruction, not how you build buildings. For now, that's not important. So the next element, maybe the most important element, is the vertical elements. They are columns. So I know those columns. Their purpose is to transfer the loads to the fundament, the ground. There are different types of loads. There are dead load from the weight of the building. There are live loads from the humans and from the furniture. And there are loads from the elements. It's snow, wind. There are special loads like explosions. They are called special because they didn't occur
Under normal circumstances.
under normal circumstances.
Desirable.
Of course, some of the structures take into account this. For example, bridges and tunnels especially, are calculated for the blast. If something goes wrong in the tunnel, you have to know and you have to make sure the lining of the tunnel will withstand the blast. Otherwise, it will gonna be a much bigger disaster. So, but most of the buildings, typically public or residential, are not doesn't take into account blasts. Because I'm told you this because in my practice I stumbled twice with buildings that are blast proof. One of them is a bank in London, and the walls and the curtain wall was blast proof. The glass was really so yeah, in certain circumstances you take into account the blast. If there is a terrorist attack or something like this, you have to make sure the construction stays intact and doesn't collapse. Maybe there is a damage on the envelope of the building or some of the elements, but the construction stays intact and the occupants escape safely. So yeah, blasts are not only in CG, they are in real life also.
Unfortunately.
Yeah, it happens. So yeah, let's move back. The columns, their purpose is to transfer the loads to the ground. So on top of the columns we have beams or slabs or roof structures, which can also be mesh of beams, something like this. But we have top structure, which actually holds and withstands the load itself and transfer it to the columns. And the most critical part is the connection between the beam and the column, because it depends from the type of connection, the behavior of the building depends on the connection. Actually, if you have a rigid connection between the girder, beam, and the column, the building will shift relevantly small to the lateral, from the lateral forces. For example, if you have skyscrapers are made with joints, not the rigid connections, because you have an internal core, which is actually the part which withstand the lateral movement. The typical example is a warehouse made of steel beams and columns, because the joints should be rigid enough to hold the wind. Because it's a one-story building, you don't have enough space to make space trusses, or not, you cannot make them everywhere, so most of the joints are rigid. But most of the buildings are not built that way, because to make a rigid joint, you have to make it really solid. When it's steel, it's not a huge problem. When it's concrete, it's a huge problem, because you have to have a certain section of the elements in order to make reinforcement go through sections. And actually, people are avoiding this, making joints between the column and the beams, more movable, let's say like this, because we're talking about little angles of rotation. They're really small, but we cannot say that it's rigid when we have a rotation. So how, if we have all the joints are movable or they can rotate, how we can make the building stays? We make concrete walls or space trusses, which are just a second. On the top picture, there's this X joints. Which actually holds the lateral forces.
Just this window and W to draw. Yeah, we went to.
So that's a space truss. That's a system of connections that actually holds the building in place from the lateral forces, from the wind and the earthquakes mostly. And this actually is the most important part of the building. The typical building, we have a core made of concrete, reinforced concrete, which is a solid U or O shape structure, which typically holds the staircase and the elevator shaft. It's in the center of the building, and it will make sure the building doesn't shift. The rest of the structure is only columns and beams, which are put together to hold the dead load, the vertical load. But the core holds the lateral movement of the building. So when you destroy the building, you make sure you destroy the core, because this is the most rigid part of the building. There are a number of cases when the demolition guys blow the external, the envelope of the building, the external columns, but the core stays intact, and actually the building strips its columns and beams, but the core stays I don't know, 80 meters in the sky, and this is a problem because you have to do it again in the partly demolished building. It's not a pleasant job to do. So that's the core of the building, and on top of everything we have a roof. Roof is like every slab, but it has a different purpose actually to hold the elements away from the building. So that's the structure of the building basically.
And what about the walls, like the outer and inner?
Walls typically are only to protect from elements if they are envelope walls, or from noise, and just to separate the spaces. They're made from bricks, they're not load-bearing elements, and actually they are only dead load to the building.
Yeah, decoration.
Apart from the core walls, which are made from concrete, reinforced concrete, and they have different purpose apart from sound isolation. Some of the buildings, like residential block, typically 50s and 60s and so on until 80s, are made from panels, and they don't have columns and beams. They have walls which are load-bearing elements, and they are welded together, and they make actually boxes, and boxes are on top of another. So recently there was gas accident in Russia.
Yeah.
In Lublin also.
That's
Consequences. And what happened was that a gas bottle blows in the second floor, I believe, and the whole building collapsed because it blows several walls, which are load-bearing walls, and the rest just crumble.
How big was the gas bottle, or was it just the building that was weak?
Or maybe old.
In Russia, the gas bottles.
Both of them are.
Biggest non-conventional gas bottle.
Well, the problem with this is that this is an easily compromised structure. It's because the column is some kind of thin element. When you have a blast, it doesn't have a big surface that will take the blast. So the blast will goes around and continues. It demolishes the wall, but the column, if it's not a huge blast, it will stand. But when the wall itself is a load-bearing part, it takes all the pressure from the blast and actually flies away. And the panels above has nothing to hold them; they crumple. And actually, when they fall, they pull the rest of the structure because it's welded structure. It's like a domino effect because and I will show you several demolitions and you'll see the same effect. This is the no, not exactly, but if you want to demolish something, you blow the core, the core crumples and pulls the rest of the building in the footprint of the building. Because you demolish them, for example, if you demolish that column, actually that space is it's empty, and the column from above starts to go down and starts to pull that, and that is a domino effect because actually the column is the purpose of the column is to hold the vertical wall. There is no big section of the column when the column starts to bend.
Yeah.
Starts to crack.
Is that why it's look like that? It's like a globe? You know, it's like just when they demolish the big look like that, it's like a globe and it's just folding down.
Yes, yes, that's the case.
It sounds important because I don't think that we take these things into account. We don't model the different the loading, the carrying structure differently than just the walls. So if we make it so that the carrying structure, if something happens to it, then it can pull everything else with it, and the rest of the stuff is much softer and easier to deform and to get destroyed. We would get a more like this kind of a domino crumpling effect, maybe. It's worth trying out.
Yes, the thing is that when you start making a building, you start with the structure, the bare structure. It's like in real life when you see the people start building a house, they start with the structure, and once the structure is finished, they then fill the walls with walls.
But basically, the just dividing walls and this kind of stuff, this does not play into the structure at all.
No. Apart from this case, when the wall actually this wall bearing part, typically these walls are made only from bricks. Bricks are way less rigid than the concrete. So if the blast occurs here,
We didn't know that.
wait.
Okay.
Right?
That's good to know.
Actually, the brick wall bends and then flies away. Actually,
Yeah.
the connection between the bricks itself, it's a mortar, it's like a sand, and it's not very rigid.
I think that's something that's also very important for us, because this means that when you simulate the structure and stuff happening to it, you can simulate with just the structural elements. The rest of the stuff you can add next when they react to the structure which has already acted. But you don't need the rest of the stuff, which is a lot of stuff you don't need in the structural simulation, because it doesn't do anything.
And for the rest, like the walls and the bricks, that we can actually maybe consider them as some kind of simulation, as like a preset for like one block, and we can have it bent to a certain standard. Maybe do like similar to what they do with creatures with the skin and the stuff like that. We can have that as preset, and then just simulate the joints of the structure.
Basically, what blows away is the walls. What crumples is the structure.
Yeah.
If you have a big enough blast, you can erase the walls, but the structure will just crumple because there is no column over there. But the roof won't fly away.
Yeah, this is also very
It
important.
stays there and just crumple because it has a weight. The gravity is still there, so all the things which left behind from the blast just goes down.
Yeah, these are two visual different things. One of them is things getting blown away, and the other one is things falling down.
Yes, and you know what is the blast? It's a bubble, the hot air, and it goes in all directions. Let's say.
With a certain speed. Right?
Yeah, but uniformly. If it's not some kind of special blast, but typically it's uniform bubble, and things which flies laterally flies faster than things that fly vertically because of the gravity. Because gravity wants to pull them back. So maybe initially they fly with the same speed, but really soon the top part starts to slow down and eventually fall down. So
what about the D there? So I think basically the question is, does the column go from the bottom to the top without any interruption, or it's somewhere at floors or somewhere else?
So
it's spliced, I think it says there.
like this is for example, this is the steel structure. This splice actually connects the bottom column to the top column. This
And
is a joint.
Why is it above the floor there?
Because it's easier to install it.
Okay. That sounds good.
Just like this.
Makes sense.
This is the trivial answer. The most complex answer is you don't want to concentrate the connection in one point, because here we have different loads cases, and if you put the column splice there, you increase the chance that something go wrong. So you just move the point.
Offset the
Yeah.
okay.
So that's the reason. And this splice actually is more rigid than the column itself. This is the common principle in construction, that the joints which connects the same section are as strong as the section or more, because you have to be sure that the section is continuous. You don't want to be way more stronger, because in that point you bend that part, and the middle part stays really, you will be really strong. You don't need this. because you need the structure to be
To distribute the
no,
force
no,
evenly.
как и предвидим?
Predictable.
Predictable. Oh, sorry. To be predictable, because when you make structures like a car, when the car hits something, you have to know, you have to make sure it crumbles the right way. Here is the same. You have to make sure the structure bends or deflects in a predictable way. And when you place these weird joints, which are really strong, they actually change the way the structure behaves. But we assume that this splice is as strong as the section itself, so it doesn't take into account some changes there or some anomalies. And actually, let's back to the question: what happened if from the base example? What happened if that part of the column disappear for one reason? If there is no blast, if you, let's say we cut it or pull it somehow, the weight of the rest of the structure has nowhere to go. The capacity of that column, it's not sufficient enough to withstand the bending of the slab. And actually the structure starts to go sideways. That concrete wall will stay where it is. It's way stronger than the rest. So when you pull that column, nothing happened to the. What will happen is that three joints will tear apart, and that's it. And we have a pile of columns and beams on the base, but the rigid structure would stay the same. What happened if you demolish that part? Everything will fall to the right because there is no structure to hold the lateral forces. And actually the weight of that concrete part is way more than the rest, and will pull all the members to the void and will crumple.
Now, maybe one of the main questions that I have maybe, and we were discussing is, what if there is a blast that hits a building in some higher point,
Mm-hmm.
and the foundation is still intact, and the bottom columns are also intact.
Mm-hmm.
But what happens if the top, how does it collapses from the top down when the heat was on a higher level?
Okay, so initially, let's say we have a blast in the center of the building.
Mm-hmm.
The bubble starts to rise and starts to rise uniformly
Mm-hmm.
until it hits something. It hits floor and hits the ceiling first. And if it's big enough, it will rupture the ceiling and the floor, and will continue to expand to the outer walls. But physically, there is a second blast because of the reflection until the floor is ruptured. So there is an oscillation inside. So, for example, if the blast is here, most of the energy will goes in that direction because this is a really strong wall.
It's going to
And
reflect.
going to reflect, and actually the damage here, there will be a damage, but it won't collapse, and all the energy or most of the energy will goes in the left direction because it's next to the really rigid place. What will actually, if it's here,
Yeah.
first that column will go,
Okay.
and the slab above will start come down. Because of this, that beam will start to go in that direction, but the blast continues, and will bend that column, and everything will actually start to rotate clockwise. And what will occur in outwards, we will be that wall, actually the outer wall will come outside, and maybe more, not
All the
more.
windows and the frames.
Yeah, of course, yeah, but the ceiling structure, maybe some of the members will go in there, but most of them will crumple.
Okay. And
If that wall is not that strong, that situation will be replicated in the right, but let's say symmetrically.
Okay, so so yeah, one element is the blowing aside of non-structural stuff, and the other element is the collapse of the.
The collapse of the building has logic, and logic is opposite of the building,
The
construction
construction.
of the building. You start to demolish something, and it goes from one point to the next structures, and they fall in a logical way. For example, the whole outer wall won't fly away or won't fall as a one piece, because the rest of the structure then what happen with it.
and we try to hold to keep.
Yeah. So when you make a model of the building, it's important to make the model of the structure of the building. Or when you receive the model of the building, because someone gave to you, it's important to, or at least in a large extent, to understand what is the construction of that building. If the model have the internal walls and so on, you can recognize where the core is, and you assume that is the most rigid part of the building, and the rest is just envelope and partition walls.
And the core is the concrete part where that holds the stairs and the most the heaviest structure.
Typically, yes. When you see the
But
staircase,
because there is sometimes staircases and elevator shafts that are outside of the not in the center of the building.
it doesn't necessarily the core to be in the physical center of the building. It can be shifted. Some of the building has that core actually on the perimeter of the building. But in that case, you have other core inside, because this is more
Advanced stuff.
advanced stuff. But if you have a building, and that's the core. Let's say you have wind, which blows from one direction, and the whole thing actually.
That's top-down view, right?
Yeah.
That's the building. That's
Yeah.
one.
Top-down, I mean.
Yeah, that's the plan view,
Yeah.
and that's the, let's say, elevation.
Okay.
Really basic, but actually that's the way it is, and that's the wind bends like this. But if the building It's like this. Here's the core.
Yeah, exactly.
If you have the wind, the building will rotate because we have a concentrated
Around that
stiffness
original
in one of the corners, and the building will rotate.
Twist.
And
Yeah,
how
twist.
much is like a sector angle, like
On-
just a generic something, average stuff?
It depends.
That
on
building can move because when
it depends how high it is. If it's 1 story, it can move a few millimeters.
let's say
If
like
it's
7 stories or 5 stories or something like that. Just a rough number, really.
I don't know, let's say a centimeter
A centimeter.
maximum from the most extreme.
Yeah, that's a
forces.
good example.
Yeah,
Because
if you
I know
have
that
100-story building, you move several centimeters. Then
okay.
more. It depends on the structure. If it's a steel structure, it moves more than if it's a concrete structure, because the steel will, it's more tolerant to. Actually, the rotation is counterclockwise, but anyway, it for our point of view, from engineering point of view, this is not good because you put additional stress to the structure because of the twisting. So
The balance.
yes, or make a big core in the middle. So to compensate for this, because sometimes the architect just want a big staircase in one part of the building, one edge, and this is a staircase. Let's say that this is a staircase. And you cannot move it. It's there. And so what you do, you make the partition walls here in the center in concrete. There, make them thicker, stronger, and they will fulfill the architectural view of the building, but you want to make them stronger. There is a term, engineering term, that's called it's center of the masses,
Yeah.
center of the weight of the building, and you won't be in the center of the building.
It's
Otherwise-
like in martial arts.
So yeah, it's good to start when you see a model of the building to understand or basically see where the structure is, because this will tells you in not really precise but general will tells you how this will go down, because there is, as I say, logic in demolition. I want to play some videos about this because it's
Can you just turn off the sound?
No less accurate than surgery. Today you will see how Moscow City street advertisement
Yeah.
sorry. Okay, that was a close angle, but so what we see here that the people demolish some of the structural members, mostly columns, and they want the columns to disappear in a second, and under the slab to become a void. The main force in demolition is dead wall, it's gravity. So the gravity do most of the work. You want the building to behave in such a manner that the gravity will place it in its footprint, not away, but in the base of the building. Otherwise, it will become dangerous. At least.
So there was a thing which happened with the last building there. So
sorry?
it went. There was a thing which happened with the last building there, which where it went to the side.
Because
Yes,
it was put to- for
in that example, you demolish because it's building with several cores. There is in big buildings you don't have uniform shape, uniform core. Of course, you divide it in several pieces, and you demolish, for example, the right part. And actually, when the right part starts to go down, it pulls the left part with it, and this helps you actually to demolish the whole thing. Because once the building starts to go down, there is inertia forces which are really strong, and the building actually cannot hold them. This is the sorry.
So the
This is
rotation that happens is because of the pulling.
Yes. This is the next example is when you demolish bridges. You want to make them absolutely simultaneously, because you don't want something to pull some other part because it's a long object, and you don't want something to start to pull away. So you want always everything to go straight down as soon as possible. Otherwise, it goes laterally, and you don't know how to overcome this. This is the next example when that's the bridge. Actually, and the piers start to go after everything else because they're very higher than the rest. That's the course. Yeah, they go first. It's not, and in order not to mess around with the rest of the structure, make sure you pull them first, and then the rest goes on the base.
Okay, but this is a directed, well,
Yes.
precisely put explosion. What happens if the explosion is like, let's say the building is hit by a rocket or?
Yeah, most likely it's only gonna destroy the
Unfortunately,
stuff, the walls and
I didn't see that much cases.
We have one very, very, very famous one.
About no.
The famous one is again the core is being destroyed because
Of the heat.
but in that case it's also I think more special because the supporting
Yeah.
structure of the building is on the outside.
So that's a very important, actually, the previous one
Yeah.
video, because it shows how the concrete, like how it explodes. And I had a question about that in mind, because like the structure and the other elements are, let's say they are clear, but when an explosion happens, that bubble moves with a huge speed,
Mhm.
and the speed that it has, the energy it has, actually it moves faster than the concrete material can move. So
Yes.
because of that, it will break at certain points to release that energy that goes through. And the question is, how can we know how the concrete will hold on larger pieces or will crumble on very smaller debris, and when
Mostly,
will that happen?
the concrete pulverized,
Mm.
and there is no such a big rocks, maybe like a fist big, but that's the
But-
biggest.
So that's at the point of like the explosion.
Yeah, and actually, the biggest parts are not blown away by the energy, but most of the material is dust. The concrete become dust,
Yeah.
and because the reinforced concrete is a concrete which is cement and gravel, but the gravel is like a 3 to 5 centimeter big stones, and the rest is steel rebars. And once the explosion occurs, actually the cement pulverize and also bonds most of the rocks, but there is no such a big rock in the concrete that will withstand the blast. So most of the concrete is pulverized.
And then only the side walls and all the others that are the bigger blocks, they just collapse down.
Yes.
With the whole pooling action.
For this example, you have charges inside in the concrete, and because there is confined space in the hole, the energy pulverize the concrete. When you have a simple column or several columns in the basic structure, the energy bends the structure, but doesn't pulverize it because there is no area of the member of the column or the beam which holds that pressure. The pressure is big enough to bend it, it crack it, but it won't. Yeah, if it's close enough, or maybe the closest columns or beams will be, but the most of the concrete or structural members will collapse because of the lack of the several members which are blown away, and there is nothing to hold them.
Yeah. So big internal pressure can also cause the bending, which can cause rotation too, right?
Yes. Yes. Actually,
So
the
we create
absence of
rotation.
one member causes the rotation because the dead load above this absent member starts to go down and starts to pull inside. If it's on the edge of the building, most of the energy will dissipate outside, and then actually the rest of the members will start to go over the edge of the building, not inside, of course, because the lost members are on the edge of the building, but it will pull. Their absence will pull the upper slab or beam or whatever it is.
And do the floors and the beams support the columns in any way? I mean, if there is a critical, if the floor fails, there is too much load on top of the floor, and then it falls down, it breaks off from the joints to the columns, and then falls to the previous floor underneath. Will this influence the columns in any way? Because I guess it's not gonna just all the floors come down and all the columns left standing.
No. So the floor itself, it's a slab. This slab has a bending capacity perpendicular to the slab, and infinity capacity in the plane, in the direction of the slab. So when part of the slab collapses, this actually benefits the column because the column
Get released.
gets released from the load. But if this collapse, this part, it doesn't disappear. It goes down, and this force from the Earth gravity, it adds to the weight, and actually the lower slab gets more loaded. So it depends of the size of this rupture. Let's say the lower slab will withhold the load, or it will crack and will again rupture, and in one point, maybe after 2 or 3 slabs, the columns below will fail because they cannot hold the load, the load of 3
Yeah,
slabs.
they have to hold the load on the beams. Yeah.
Yes, yes. So if you cut one piece of the slab, actually nothing happens. If it's a thin slab and you fall on the slab below, nothing happens also because the slab below have to withstand its load. have to withstand the load of the slab above,
And
because when you
transfer it to the
construct the
columns.
building, actually what you do, you finish one floor, raise the columns, and then make a scaffold, and then you pour the slab above. So the weight of the slab above is held with it's held by the slab below. So one slab
It's holding one
is
thing.
holding
Yeah.
two, actually, the weight of two slabs itself and the one above.
Mhm.
So actually, if one slab is going down, typically it won't be, if it's not the whole slab, I mean one piece, typically won't be as much problem. But if there are two, then, and
Nice.
because of the inertia and additional forces, because of the gravity and the stress, this will maybe collapse the building. In the demolition, actually they cut several columns, and the weight of the slabs above goes under the below, and there is a domino effect.
Okay.
Is there any kind of rough, quick formula for calculating like an
It
explosion?
is pretty rough, yeah.
Yeah.
You don't want to mess with it.
No, I mean for us, because we
No.
we don't
For the
need
mortar.
that.
No.
So basically to calculate the explosives, or how strong an explosive is compared to how much damage it will cause to a certain.
I know Chris has a
Elements.
friend which is a demolition expert, and maybe he will explain this to you more in detail. But in construction, deflection calculations are one of the toughest, and they're really complex. So if you have a simple beam, I can give you a formula, and you still need a calculator to make it. But if you have a big construction, we need software, because it's really complex. A bending of one
Simulation.
member calls the bending of the other member, which is like a preset case for the next member, and there is really complex calculation, so you cannot make it just like that.
No, I ask because like we just want to know, like for example, if some kind of a explosion happens in a building, how far certain debris will fly off, and what kind of debris. For example, if it's like a concrete part, and it will pulverize, and then only a smaller debris will fly away.
I honestly don't know how you're going to calculate this precisely, or I don't know, roughly, because just
Just
there is
by watching
there
this
is a
episode.
workflow. First, there is no in statical point of view, there is no. I will play this just to make fun. There is no such thing as explosion. Explosion is our term, but in construction point of view, there is forces. So you have to know what kind of explosion, which forces will occur from it, and how we will apply it to the construction. There is a pressure.
That's a better.
It's a uniform pressure or force. That, and there are three types of force. There is a force, uniform pressure, and bending momentum. So we have to know how this bubble will apply to the structure, and this is not simple. And once you have these forces, then you start to calculate the deflections of the members.
Okay.
And that's cool. That's really cool. Your question is relate more to the fluid dynamics of the blast rather than structural.
Yeah, it gets very complicated because as
It
you
is.
said,
It is
starts
actually.
to
Yeah.
bounce from the
It is
every
pressure. Pressure from what? Pressure from the blast itself. Pressure from the empty space, which actually gets collapsed, and there is air which wants to get out.
escape.
Yeah. So there's sometimes they add, sometimes they don't. So
Or water.
it is complicated. I honestly never
like
thought
more.
about this.
What would it take for the building to bend and break just from the bending? Like what kind of an outside force?
To bend the building.
Yeah. So
Earthquake.
let's say there is a
Earthquake.
okay.
Big earthquake.
Any earthquake shifts the building. Sometimes
Because
it's
it
visible.
shifts the fund.
Yeah, actually you move the base, and because it's not infinitely rigid structure, when the bend starts to move, the top there is a delay. So we have lateral forces in this movement, and this is the most extreme case for the building.
These are columns disappearing.
Typically, the blasts are not big enough
Yeah.
to make such a movement like an earthquake. Actually, landslide is another thing, but let's say it's also connected to the base of the building. Yeah. If you see, there is several cases. I can show you that the building fall as one piece on the ground.
In China,
Yes,
there was
because of the absence of the fundament, and because the slabs are, as I say, infinitely rigid in their plane. When the building just falls on their side, the slabs stays intact because there is no such force that will rupture them. And this is a problem for demolition, for example, because if you don't do the job well, the building can stumble, and there is cases that you stumble on its roof.
Yeah, and it can fall to the side and
Yeah. And
Hit
this,
the next building.
yeah, it's disaster.
Yeah, because from our point of view, the rotational motions are more interesting. Like they visually have more content. So
Yeah, more appeal usually.
yeah. So that's why I'm interested in like all the things that create these more lateral and more rotational motions.
But that depends very
Yeah, because if a building just collapses down to its foundation, it all goes as we see in all the examples. It goes to that.
If you want
And
the
you
building
cannot
to
see
to
anything
fall
like that. So-
on its side, just blow the one side of the base of the building and
Yeah.
it will stand. So go.
It's like a tree.
That's it.
One
That's
part.
it. If you make an explosion in the top floor, you cannot expect the building to collapse.
Yeah.
Or yeah.
And also, what the buildings who have the supporting construction on the sides of the building, like on the outside,
Yeah.
so they would also suffer from stuff which happens on the outside or like near the edge, right?
Yeah, like in, the 9/11 example. It's a good example.
Yeah.
When the building there are constructed that the envelope of the building is load-bearing part. There is steel columns on the perimeter of the building, which holds the steel trusses on one point, and on the internal point there is a core. So the space between the core and the external walls, which are load bearing, there is nothing. And in the 11 case, when the plane explodes, it rupture the load bearing part of the building. That's
From
was
one
the
side.
problem.
Mm.
And that blast actually compromised some of the columns, initial blast. But the bigger problem there was that the heat
Melt.
eventually
From the fire.
start to compromise the steel itself, because the steel it's really weak to temperature. That was that because the fireproofing is really important for the steel structures. And but the case there was that the external walls are compromised, and the floors start to go down like a pancakes. And eventually the structure below cannot hold the weight and starts to go down. And once that happens, there is no turning back.
So if the plane actually had hit the top floors, it wouldn't fall.
It
Like-
depends of the if it hits let's
The
say
top two
yeah
It won't.
it won't happen, yes.
Yeah.
It won't happen. But for the for the lower tower, I think it happens in the 2/3 of the height, so it's quite substantial weight above the compromised point.
Yeah, you said more than two floors have to fall. So
This is a basic. It
Yeah.
always depends, because let's say
Yeah, of course,
in
yeah.
9/11 there is a thin floors which made of steel trusses and a thin concrete slab. So they are lighter than the typical floor, but yeah, typically more than two are yeah.
And any advice about when we model stuff on the inside the structure, the thicknesses of the supporting elements compared maybe to the building, because this would be very useful for us when we model. Most of the times
Yeah, that's-
we either have the reference pictures of the building from the outside, or we have models which are ready, which do not contain stuff on the inside, so we have to model the supporting structure. And for us it's important to be able to kind of make them with proper thickness, so that they're
So,
not like too big or too.
For your point of view, and if you want to be a more exciting view, so it's important to make the core of the building and the outside walls.
Mhm.
If you start modeling the partition walls and so on, it only like the model.
It's gonna make it heavier, but not
It's
more
not- yeah,
structurally sound.
Yeah, it's not that important, because you want the blast goes outside. So you have to know that if are the perimeter of the building is structurally a load bearing part, or it's only an envelope. This is, from my point of view, most important part. The core will stay where it is, or if it's a big enough blast, we will blast all the building, the whole building. But in most of the cases, the core will collapse, of course, but it won't shift left and right, whatever it is. Actually, the envelope is the most important part for you, and how it will behave in order to look right.
Yeah.
So you have to examine the model, if it's if it's a concrete wall, if it's a brick wall, if it's a glass, what kind of envelope it is. Typically, if it's a glass, it's only element envelope. So if the outer wall goes out, they won't affect the construction at all.
The structure.
Yes.
So, so the whole floor is only held by its connection to the
Columns.
core.
Yes.
So it's not
And
held at all on the other side, on the outside of
It
the
is
building.
held, but with columns which are small compared to the surface of the envelope. So
Does this mean that if this column goes away on the outer side of the building, the floor would tilt? You know, like
yes.
Yeah, the building
so
will
it's not gonna detach from the side, or it's gonna still remain supported by the core, but because it's not supported from the
It-
side, the periphery of the building, it can like tilt to its side. So
The whole building won't tilt.
yeah, I mean the
the
floor
The
slab.
floor will tilt. Actually, will.
Because
Like
I
I
think
said,
I've seen a lot of
if you remove supports from the edge, it will go
yeah.
like this.
I think I've seen a lot of these in the Syria photos, where you see buildings who have suffered from like
Yes.
like a
Yes,
blow from
you
the outside.
see pieces of the ceiling or of the floor
Yeah.
hanging
Mhm.
on the wall.
But they are
Because there is a structural reinforced rebars which holds the slab itself to the core.
so, yeah. So that's a very important moment here, where when an explosion hits something in the core of the heat, it will vaporize the concrete, but then the outer parts will just go towards that and go down, and also towards from the force of the gravity.
Let's say
Down,
like this.
and the rebars will try to hold them, and that will
To
will
pull.
all the buildings, the outer walls.
Every slab is supported by the columns. If you demolish the columns below the slab will go. For example, here,
Meaning that the like walls with connection in rebars and concrete will not fly away because they are too heavy and they will just collapse.
it depends where the blast is. Okay, the concrete above the blast, will, of course, will fly away. If it's 2-story below or next part of the building, it won't. It will just bend and crack, but it won't vaporize.
Mhm.
Only the closest things.
Yeah.
So if there's something which is a big flat surface, and it has a big blast wave near it, and it doesn't have enough room to escape, this big flat surface is going to be basically moved by all the energy as it is.
Of course, yes. It won't move, get bent and pulverized.
So
There's
good case for Vlad's roof. We have a roof which
There
we
is-
detonate something underneath the roof, and we think, you know, if you know we are blowing away a piece of the roof because it looks visually interesting, but we are kind of stretching at to where, like, can a big slab like this, you know, get completely, you know,
20 meters, 30 meters away as a whole. Like, and
yeah,
that's why we are kind of
moved in a big
questioning
piece.
wouldn't go that way.
actually there is a case like this. There is slabs thick enough and strong enough that will just fly away. Chernobyl is that case. It's a 1.5 meter thick slab which holds actually the top of the reactor itself, and when the pressure in the reactor is bigger and bigger, actually it blows away the top.
Like the
But
lid of
actually the lid stays intact. It's tumble somewhere, but it's strong enough to withstand that. But that's really a rare case.
Typical building.
Yeah, there is another case. There is it's called blast welding. You place a thick steel plate, lay it with plastic explosive, and place another thick steel plate. Blows the explosive between two layers, and they become one. So there are materials and construction that are strong enough to withstand that kind of blast, but they're not in the buildings. Typical building, I mean. So if you want to blow the roof will bend if it's a slab. If it's a typical shed roof or there is tiles, they will fly in the shape of the bubble, but there is no such structure which pops and stumble or
One go at once.
it's
It's
not.
large piece.
Doesn't have.
Yeah, the bending.
And it looks weird.
No, I think actually I think that we have the bending, so it bends on this side in the shape of the bubble, and then we tear it up. So, after it gets torn up, then it's questionable. But I think we have.
The
And the start is
physics actually, the construction started to bend, and in one point rupture.
Yeah, exactly.
And that
Yeah,
from
we-
that point the fireball starts to
Escape from there.
and then
And also about the columns, so it's something that I watched in a documentary. I think that they're in places where they have many floods. They are building the buildings with with columns that are made so when there is a flood, the water will just go around the columns, and because if there
There's
is
no wall.
yeah,
It's just
so the energy goes around and always tries to find a way to escape
yes.
with the empty space. So in that case, when something hits, the outer walls will take the pressure because there is no empty space, and because they are weaker than the structural elements, and also they are much larger surface to get blasted at. So would they also crack if they are made from bricks? Would they hold or?
It depends on the structure of the wall. If it's bricks, they will just fly away like particles.
I mean, they
Because they are
cross.
disengaged from the wall, and the mortar is not strong enough. If it's glass, it starts to bend, and in one point it cracks and goes away. If it's concrete, it also starts to bend, and when because in the concrete there is steel rebars which holds tension, and they hold the tension by compressing the concrete. And actually the structure gets more and more compressed, and once the tension disappears because of the rebar cracks, then everything just goes.
So it's gonna basically explode because the
Yes.
rebar has been holding so much energy.
Yes.
So when the rebar breaks, the whole thing explodes.
Yeah, because it's the concrete is pretension.
Yeah, and that's the beauty part where I mean it's beautiful because when you for VFX of course because when you see parts of the wall and the rebars are breaking at certain points, they will hold larger blocks of concrete in between them. So if they break that could make some bigger chunks, and that some of them are linked and jointed.
This depends on
Angle.
the structure of the concrete wall itself, because there is a different kind of rebars reinforcement. One is for tension, one is for shear forces, and one is only for hold everything together while it's constructed. So if the force is not big enough, what happens? The wall cracks. Maybe it won't split, but most of the chunks are held by the additional rebars, and they just
There's cracking, but there's no.
But if you blows it, just pulverized. When you see
So left it only.
buildings from the war, which are demolished, you see that there is a missing piece of the structure, and the rest are just hanging on the core. And that missing piece is pulverized because of the energy.
Okay.
That's why I guess there's so much dust that you see in these pictures. It's not
Yes,
just
yes,
like
the
from
dust is
stuff
dust from the
hitting
concrete.
ground. It's from
Yes.
concrete exploding.
Because the concrete.
Yeah, it's not home dust.
No, it's a concrete. It's a cement. Actually, cement is
Nobody
sand.
keeps this building for like centuries.
Yeah, so that's the cement. Yeah.
It's pulverized. So. And
Interesting stuff.
anyone?
Any
And what
question?
about the other? You get many different schemes there.
The first one is typical steel structure.
No, I mean on the top.
The other tabs?
tabs, yeah, you have different schemes.
Okay.
And you only showed this one.
Sorry.
When you were passing by through the.
This explains actually the basic that
Yeah.
what is floor, what is the base, and so on. This is how it's constructed. You place the base, then the columns, then the beams, then the slab, which it depends on the structure of the building. You can have beams and columns, and on top of them slabs. Different.
The floor.
Yeah, the floor and the ceiling. Or you don't have beams and you have one big slab, which actually has the purpose of the beams. So it depends on the construction.
And generally, are the columns made out of thicker or stronger concrete than the other, like the interior or heavy
No,
walls?
no.
It's the same.
Typically, they're on the same grade. Actually, most of the cases the beams require higher grade than the columns because the concrete itself, the material, it's better to withhold pressure than tension.
Pressure is like the stuff
Yeah,
just
the compression.
pushing it to the
Compression,
ground.
yeah.
Compression rather than
And
tension.
concrete is very good in compression, but
And the slab is actually being pulled because you push it in the middle. It's being
Yeah,
stretched.
actually,
so it
the
needs
con-
more
the
parts,
column
repars.
it's always or
Yeah,
most of
because
the
rebar
cases.
are good
Good
against tension.
Yeah, actually,
Steel
when you bend the beam, you split it in half, and the lower part gets tension,
Mhm.
and the upper part gets compression. So we have the rebars on the lower part. They
They
withhold
hold
the tension force,
Mhm.
and the upper part is compressed. But because the concrete is really good in compression,
It still is good in
yeah.
tension.
So, and that's why you need a higher grade of concrete for the beams, because you need
More tension. You have more tension.
concrete also have a capacity in tension, but it's not that it's not sufficient, of course. That's why we put rebars, but
The
it
requirement
tends to
for-
crack easily. That's why you put a higher grade. You don't want cracks. Cracks compromise the air and water gets inside and compromise the steel. That's why higher grade fulfill that there is no cracks in the concrete.
Okay.
And concrete is put into the steel is put into the concrete. Can you like briefly explain like why? Or steel
Reinforced
and
concrete
concrete.
is a composite material, maybe the first composite material. And because you get the benefit of the compression capacity from the concrete and tension capacity from the rebar, from the steel, and you combine it geometrically in the way they will withstand the forces. Typically, you place the steel below or on the lower edge because of the bending. As I say, there is a tension forces on the lower surface and compression on the head. So the concrete, actually, you combined best words of concrete and steel. And other thing is that the steel doesn't rust the concrete. The concrete, there is chemicals that will, if you put steel in the concrete and then crack it after a year, it's a shiny metallic surface because the minerals in the concrete will shave or will clean the iron oxide, which is rust actually basically. So the two material works really nice together, and they're used for that purpose. The downside is that the concrete is really heavy, so that's why the high-rise buildings are not built in such a manner. They use only steel because steel is several times stronger than reinforced concrete itself.
Okay.
Cool. This was it.
What else? I think for now.
Yeah, no, it was quite comprehensive. So thanks, I think.
Thank you.
Yeah, welcome. Good stuff. Yeah, let's get a drink.
Cannot wait.
Um,
Wait. Stop.